In this video, we solve problem 11.1.046 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to find the vector v with the given magnitude in the same direction as the vector u. So we've got u equals this. It's the vector that starts anywhere and goes 1 unit in the x direction and 1 unit in the y direction. That's called the component form of the vector u. So if I wanted to, I could sketch that right now. So I go 1 unit in the x direction and 1 unit in the y direction. If we want to draw the vector u in what's called standard position, we start at the origin and do that. So we go here, we go over 1 unit in the x direction, up 1 in the y direction. That's our vector u. Now we want the vector v that points in the same direction as u, but rather than being however many units u is in length, we want it to have a length of 4 or a magnitude of 4 when we're done. So it's actually a relatively simple problem. The first thing you need to do is find out the actual length of u, and then we need to rescale this vector u and make it 1 unit long. So the first thing we're going to do is find a unit vector in the direction of u. Now, if you want to find a unit vector in the direction of any vector, and I will label that with a little hat, we're going to use hats on top of our names for unit vectors. If you want to find a unit vector in the direction of any vector, you just take the vector itself, you find its length or magnitude, and you divide by it. That's it. We just take u, find out how long it is. Let's say it was 5 units long. If it was 5 units long, I would just divide by 5. Then I would have a vector in the same direction that is no longer 5 units long. So if I take something that's 5 units long and divide by 5, it's going to be 1 unit long. We do the same thing here, but this one happens to be a different length. It's not 5 units long. Okay, so that's the plan. And now we need to find the length or magnitude of u. The calculus textbook uses that notation, excuse me. Sometimes we write it that way. I do prefer to use this notation rather than this notation. Once you go beyond calculus 3, most of the time people will use this notation. Some students find that that's ambiguous because it looks a lot like absolute value, but we know that if that's a vector inside, we're talking about finding magnitude. And again, when you go beyond calculus 3, that's the common notation. So it's good to get comfortable using both notations. Now, if you have a vector in the xy plane with 2 components, let's say in general, you've got a vector with components u1 and u2. In order to find the magnitude, you take each of the components, you square them and add them and take the square root. It's actually very easy. Now for us, our components are 1 and 1. We go 1 unit in the x direction and 1 unit in the y direction from wherever we start to find the terminal point of that vector u. So we'll substitute those in. Take the 1 and the 1, square them, add them, and take the square root. So we get square root of 2. So that tells us that this vector is the square root of 2 units long. And I think that we all know why that's true. 1 squared plus 1 squared would have to be the hypotenuse squared. So hypotenuse is 2, or the hypotenuse squared is 2. So the length of the hypotenuse of that right triangle, the right triangle that would come from just drawing that triangle right there, is square root of 2. Now, I don't want the vector to have length square root of 2, though. I want a vector v that points in the same direction as u that's 4 units long. Not square root of 2 units long, but 4 units long. So the first thing we do is we find this unit vector in the direction of u, which requires us to find the magnitude of u, and then divide by it. So our vector u has components 1 and 1. We're dividing by square root of 2. And whenever you take a vector and multiply or divide by a scalar, it's relatively straightforward. You're going to take each of those components and multiply or divide by that scalar. So we're dividing each of these by square root of 2, and we get 1 over square root of 2 and 1 over square root of 2. That is the unit vector in the direction of u. Now, if I get my calculator out and compute 1 divided by square root of 2, it rationalizes for me to give me square root of 2 over 2. If I press this SD button on my Casio calculator, it gives me an approximation. So this is saying you're going to go approximately 0.7 units in the x direction and approximately 0.7 units in the y direction. And that will be the terminal point of the vector with length 1 that points in the same direction as the vector u. So we're going 0.7 units in the x direction, 0.7 units in the y direction. Notice that it's on that same line as the vector u. That's how it's supposed to be. That's what we're calling u hat. Okay, so that's our vector, but that's not the vector that we want. We actually want the vector that is 4 units long that points in the same direction. So what we do is we take the unit vector in the direction of u, which is now 1 unit long. It's this little blue vector. It's 1 unit long, and I want it to be 4 units long. So to take this vector that is 1 unit long and make it 4 units long, I just multiply by 4. And that will be the vector v. So we have v equals 4 times u hat, the unit vector in the direction of u. So we're going to have 4 times the vector with components 1 over square root of 2 and 1 over square root of 2. I remember how scalar multiplication works. You just multiply component by component. So we're going to have 4 over square root of 2 for our x component. And if you want, you can write that as 4 over 1, multiply straight across. And 4 over square root of 2 is our y component. And you don't have to rationalize, but they probably did rationalize when they found that answer in WebAssign. So that just means we're getting rid of the radical in the denominator. In order to get rid of this square root of 2, I would need to multiply by square root of 2. That's legal as long as I also multiply the numerator by square root of 2. That way I'm just multiplying by this well-chosen 1. So it'll change the way that the fraction looks, but it's not going to change the value of the fraction. I'm just multiplying by 1 to make it look a little different. So we have, if we multiply across the numerator, we get 4 over root 2. Root 2 times root 2 is 2, or if you prefer, it's the square root of 4. Square root of 4 is 2. And this is exactly the same. And now you've got this whole number 4 divided by this whole number 2. You can take 4 divided by 2 and you get 2. And the square root of 2 is still there. So you get 2 root 2 for your x component and 2 root 2 for the y component. Hope that makes sense to you. Okay, now let's actually work that out on our calculator. That's the exact answer, but we want maybe a numerical approximation so it's a little easier to graph. 2 times the square root of 2 is this, about 2.8. We're going to go about 2.8 units in the x direction, about 2.8 units in the y direction, and that's going to be our vector v. So let's go over here and see if that actually makes sense. There's x equals 2, there's x equals 3. Here's y equals 2, y equals 3. So I want to go out 2.8 units in the x direction, 2.8 units in the y direction. And hopefully it's along that same line, y equals x, and it is. And that is my vector v. Notice that it goes in the same direction as u, and it looks to be about 1 or 4 times as long as this blue vector, which is the unit vector in the direction of u. So you take this, you make it 1 unit long, and then to make the whole thing 4 units long, after you made it 1 unit long, you multiply by 4. So our answer is this, and we can type it this way. That's in component form. Or if you prefer, you can write it in terms of standard unit vectors. So we might say this is equal to 2 times the square root of 2 times I hat plus 2 times the square root of 2 times j hat. And all that means is that if I add these two vectors, I hat is a vector that's 1 unit long that points in the x direction. This is saying, take that vector that's 1 unit long that points in the x direction and then multiply by 2 times the square root of 2. So you end up about right there at about 2.8. This is 2 times the square root of 2 times I hat. Now, if I take that vector and I add tip to tail, 2 times the square root of 2 times j hat. Now, j hat is a unit vector that points in the y direction. So just goes straight up 1 unit. And if I take that and I multiply by this number, which is approximately 2.8, if I add those tip to tail, this vector plus this vector, I get that red vector. So you can either use this notation or this notation. Either way will work. I hope that helps. I hope that you understand not just the computation, but the concept. If you don't, let me know, and I'll be happy to go over it with you.